In this problem, we're going to solve this equation algebraically for all of the angles in between 0 and 360 that would satisfy this equation, so wherever the two sides would be equal. Before we start, I'm going to look at the graph. And so this purple sinusoid is representing 7 cosine squared, and then the 6 cosine is represented by the blue function right here. And so we're looking for where they're equal, so that's going to be these 1, 2, 3, 4 intersection points. And you can see that each of these intersection points are unique because this is where both of them are decreasing. Here's where this sinusoid is at a minimum and this one is decreasing. This sinusoid is also at a minimum, but now the blue one's increasing, and here they're both increasing. And so they're each a little bit different, but I'm looking for 1, 2, 3, 4 answers, and that will help us when we solve this algebraically. So right away, if you can think of this as a quadratic, and I could rewrite this as the quadratic 7x squared equals 6x. The method that we would use to solve a quadratic is we would subtract over the 6x, set that equal to 0, and now I can factor out an x, and I'll be left with 7x minus 6. What this then allows me to do is set each part equal to 0. So x would be 0, and x would equal 6 over 7. So we're going to use this same idea now to solve this equation with cosines instead of x's. So I'm going to subtract over the 6 cosine. So I'll have 7 cosine squared of theta minus 6 cosine theta. Now I can factor out a cosine theta, and I'm left with 7 times the cosine of theta minus 6 equals 0. Again, I'm going to set each part equal to 0. So I'm looking for where cosine will equal 0 and where cosine will equal 6 over 7. And so I now have 2 equations that I need to find all of the answers for theta for in this specified domain between 0 and 360. And so right away, if I think about my unit circle, cosine corresponds to the x value. So cosine will be 0 at 90 degrees and at 270 degrees. And so any angle beyond that is going to be larger than 360. So my only answers from this part are going to be 90 degrees and 270 degrees. There's no need to find more. Now here cosine is equal to the ratio of 6 over 7, and that's not a ratio that we're familiar with on our unit circle. And so from here, to find theta, I'm going to have to do the cosine inverse of 6 over 7. Now remember our work from exploration 7.4a. I know that there's more than one location on the unit circle where cosine is positive. And so cosine is positive in the first and in the fourth quadrant. And so when I do the cosine inverse of 6/7, that's only going to give me the answer in the first quadrant. So I get a positive 31.00 degrees. That means that my other answer would be negative 31.00 degrees, or that would round to 31 degrees. So from here, I don't really want this answer because I can see that it's not in between 0 and 360. This does help me get 2 general solutions. So 31 degrees plus 360n. My other answer then is negative 31 degrees plus 360n. And even though this negative angle isn't going to be an answer, I could add a multiple of 360 to get an answer that we do want. And so I'm going to keep that entire answer in my calculator. I'm not going to round it even though I've rounded it here. So I'm going to take the negative of that angle and add 360. This angle is in this domain, and so one of my answers will be 328.997. 31 degrees is in this domain, but if I added 360, it no longer would be. So this is the only answer I want from this solution. So now you can see our 4 answers. They came from this first part of the equation, 90 degrees, 270 degrees, 31 degrees, and 328 degrees. And again, this is a rounded answer. We have 4 answers, so now we want to verify that these match with what my graph is saying. And so you can see here's 90 degrees, here's 270 degrees. This looks roughly to be 31, and this looks roughly to be 328. So I know that those are reasonable answers, and we have all 4 solutions that would satisfy this equation in between 0 and 360.